There we go. Welcome, everybody, to Chapter 8. Chapter 8, you are going to see a lot of fractions. I mean, fractions and fractions and fractions and fractions. Not a lot of review from Algebra 1 happening in Chapter 8. We hit the concepts that we're going to hit in Chapter 8, we hit pretty lightly in Algebra 1. And then in Algebra 2, they get a little more intense. Let's start with just 8.1. The very beginning, inverse variation. So inverse variation implies as one thing goes up, another thing goes down. Whatever those two items might be, think about a word problem, or it's like as x goes up, y goes down, and as y goes up, x goes down. They're inversely related. Your goal is to recognize and use this and other types of variations as well. So let's talk about old school. Chapter 2 is when we talked about direct variation way back when. And direct variation was used to describe relationship in with both variables increase or decrease at the same time. So that would be like as one thing goes up, the other thing goes up at the at a constant rate, and as one thing goes down, the other thing goes down at a constant rate. So they're either both increasing at a constant rate, or I guess we could say they're both decreasing at a constant rate. Now, what was that constant rate? That was that k value. The equation was y equals kx. Notice it's just a modified version of y equals mx plus b, where b is 0, meaning I go through the origin. For example, the more oranges you buy, the more money it costs. So that's a direct variation. Like it's not going to change. Like a bag of oranges is 3.89. So you buy another one that's going to double. You buy another one, you're going to have another 3.89. It's constantly going up at the rate of 3.89. Inverse variation is used to describe relationships in which as one goes up, the other one goes down. The equation still has that constant of variation because we're still in variation. We're just an inverse variation. It's y equals, instead of y equals k times x, it's k divided by x. So that, if you would look at a graph, you would say, oh, okay, so as x gets bigger, the value of y is going to get smaller because when you divide by something bigger, your outcome is going to be smaller. For example, if the more time you spend on your quad, the less time you're going to spend on your algebra homework. That's inverse variation. In both cases, K stands for the constant of variation. Constant of variation. Ta-da! Okay, so here are our steps to like the problems today. First thing we're going to decide is whether a problem is direct variation or inverse variation. And I should also note that later in the lesson, we're going to have both things happening in a problem. So determine if it's direct or inverse. Determine what the two things are and assign them to X or Y or Q and R or whatever variables you want to use. Plug that information in, solve for the constant. Every problem is going to have a constant if it is direct or inverse. And making an equation with k, fill it in. So it's going to be like y equals, like 3x, or maybe y equals 3 divided by x, depending if it's direct or inverse. And then you're going to use your new value of k and your new equation, and you will solve for any values of x or y. So you're going to have information. You're going to make an equation from that information, and then you're going to be able to use that equation and apply it to many, many, many situations. Part one, let's talk about what happens if we are given a table of values or numbers. First, let's see if it's direct. By the way, if it's direct, they're both either increasing or, I did that backwards. They're both either increasing or they're both either decreasing. So that's how you know if you're going to test for direct. All right, okay? So let's take a look, unless it's negative. Okay, let's test for direct. So here's how you test for direct. If y divides by x, and it's the same each time, that makes it direct. So you'll have y equals kx. By the way, whatever you get for y divided by x, that's what you get for k. Like that is your k value because you'll get it every time. Um, The only thing I think I should probably mention is that you can have direct variation, one going up, one going down, if the constant is negative. But like I want you to think in terms of absolute values. Like this value is going up and this absolute value. So you want to think of them as absolute values in that kind of sense. All right, test for inverse. So to test for inverse, you're actually going to do, instead of y divided by x, you're going to do y times x. It's opposite of the equation. Um, and if it's the same every time, that's inverse. So it's y equals k divided by x as your equation. By the way, whatever you get for y divided by x, that's what goes in for k. If you would like think about solving this equation for k, you would you would multiply both sides by x, right? And that would tell you why k is y times x. Okay, if it's not the same each time for either of those cases, then it's not inverse and it's not direct, and you just write no, and you can't come up with an equation right now. So let's take a look at these three examples. The first thing I want to note is I can see that the x values, as I go down the list, I can see that the numbers are getting bigger. So the x's are getting bigger. See how it goes from 0.2 to 1.5. And I also notice that the y values are getting bigger. So I'm going to test for direct. I'm going to try direct. So to try direct, what I need to do is, I'm going to do y divided by x. So I'm going to do 8 divided by 0.2. I'm going to do 20 divided by 0.5, 40 divided by 1, and 60 divided by 1.5. And you're going to do that every single time. You're going to get 40 here. You're going to get 40 here. You're going to get 40 here. And you're going to get 40 here. If you don't believe me, use a calculator. So since I got the same thing every single time, that does in fact tell me, like, yes, this is actually direct. So I can give a little check mark. I can write direct because I did the direct test. And so I can write direct variation. The equation is pretty easy. It's y equals the 40 times the x. Now let's try part B. So what I want to notice again is that the x's are increasing and that the y's are decreasing. So I'm going to change color so it doesn't blend too much into the other problem. So I'm going to test for inverse because I see this like odd like up and down situation. So to test for inverse, I'm going to do the inverse test because one going up, one going down. You are going to take your y values, so 40, and divide it by your x. Nope, other way around. Silly me, I got to follow my own notes, don't I? I need to do my y values times my x values. So I'm going to do 40 times 0.2. I'm going to do 16 times 0.5. I'm going to do 8 times 1 and 4 times 2. And every single time I get a big whopping 8. So because I get the same thing every single time, I'm going to give it a little check mark. Whatever I tested, inverse variation, is correct. And the equation is y equals 8 divided by x. That's your inverse equation. All right, let's take a look at part C. So part C, what I'm going to notice, I got all positive, so I don't have to worry about that absolute value business. As the x's are going up, the y's are going down. So I'm going to try it for inverse. So inverse says, I'm going to look at my test. Inverse says to take my y's and multiply them by my x's. I'm going to change colors so they don't blend in. So I'm going to take my 40, multiply it by my 0.5. I'm going to take my 12, I'm going to multiply by 1.2. Let's just check those. 40 times 0.5 is 20. 12 times 1.2 is 14.4. I don't need to go any further. It's not inverse. So just to play it safe, we could definitely check direct variation if we wanted to. Real quick, we could do our y's and divide by our x's. Let's see, 40 divided by, that's 80. And I could do 12 divided by 1.2. I'm going to need a calculator for that one. One moment, please. Oh, I'm so silly. That's 10. I should have known that. Okay, so again, like I just did a double check. It's not direct either. I mean, I kind of assumed it wasn't going to be because it wasn't doing like the up, up, and the down, down thing, but there's nothing wrong with being careful. So it's neither. When it's neither, there's no equation. It's not possible to make an equation for what we need right now. All right, let's move on to problem 2. Now, I know you're so excited. It's like, I wonder what the graphs look like. I know I know you want to graph these puppies and see what they look like. That was really on your agenda for today. So problem 2, determining an inverse variation. Let's see here. Suppose X and Y vary inversely. Just that phrase in and of itself is very important. So, okay, what does that phrase mean, Miss Langeli? That means that Y equals K over X. That's just an automatic. If it says the inverse if they vary inversely, then we know the equation has to be it. So let's fill that equation in with x equals 4 and y equals 3, and let's solve for k. So I get 3 equals k over 4 multiplied by 4. That's 12 equals k. Now, a lot of kids just stop there. They're like, yay, I got my equation. No, you didn't. Your equation is y equals 12 divided by x. That's the equation. You have to get k in order to get your equation. Now, this equation will work for any situation. So you see how it says, what is y if x is 15? Well, that's y equals 12 divided by 15. If I reduce that, what's that going to be? It reduces by 3, so 4 over 5. So y is 4/5 if x is 15. Now, let's graph this. I wonder what this could potentially look like. I am so excited that you're excited because that just makes math fun when we all get along. All right. Now it's like, what x values do I pick, Mrs. Langeli? So I got like y equals 12 divided by x. Well, we want to get a pretty picture. That's our goal. We want to get a pretty picture. So what I'm going to do is I'm going to pick things that 12 divides by, and I'm going to see if that's good enough. And we're going to need some negatives and some positives so we can actually see what it looks like. Now, I know you've already, right, my overachievers, you've already gone to your calculator and you have already tested this to see, oh, that's a neat little graph that we're going to be getting. That's kind of wonky, isn't it? Okay. Let's do 12 divides by, well, 12 divides by negative 12. So in my equation, I'm going to do 12, which that's what it says. This is 12, divided by what I plugged in, and I get negative 1. Okay, so negative 12 and 1 is a point. I'm going to try negative 6 because I know that goes into 12. 12 divided by negative 6 is negative 2. Okay, what about like negative 4? 12 divided by negative 4 gives you negative 3. What about, I guess I could do negative 3. Gives you negative 4, and then negative 2. 12 divided by negative 2 is negative 6. And what else goes into 12? Now you could be like, Miss Angeli, do I have to pick things that go into 12? Nope, you really don't. I mean, you don't have to if you guys don't mind working with decimals. You just want to get a really pretty graph. And then you could get 0 and you could do like 12 divided by 0 and then you'd be like, "Oh no, the world just blew up," because you can't divide by 0. Let's see if I can fit 12, negative 1 on my graph. Oh, it'll be right here. I'm just going to plot it right there. So that's negative 12, 1, negative 6, 2. Here it is. Negative 4, negative 3. Negative 3, negative 4. And you can start to see the graph, like the shape coming to be. All right, let's see if I can get this negative 112 on there. It's going to be somewhere down here. Good enough. But what I want you to see is this has two asymptotes, just this side of the graph. It's going to approach the x-axis and never touch it, and approach the y-axis and never touch it. Let's see. Usually I have a piece of paper, and I can turn my piece of paper. Okay, and then so it's going to approach the x-axis, it's going to approach the y-axis, but never touch. Now, that's just the one half of the graph. That's just the negatives. I still need to do what the positive side of the graph is going to look like. Oh, I know you guys thought this was going to go fast. You'd be wrong. Okay, so what positive numbers go into 12? Well, how about positive 12, positive 6, positive 4, positive 3, positive 2, positive 1? And if we try to divide by 0, we'll be like, oh, bummer. All right, so 12, let's plug in 12. 12 divided by 12 is 1. 12 divided by 6 is 2. 12 divided by 4 is 3. And then just fill that in accordingly. Pause the video if I move too fast there. We're just putting those in for values of x and dividing. So let's plot them. Again, I know you're excited. Don't you love how when I give you guys graphs, it's always like one short? Let's see. I'm counting quietly in my head. Right. Good enough. And you can see it has the same shape as the other one. Oh, this will, I'm really bad at these all of a sudden here. Whoosh, I just missed all of those points. That's better. So it is very important to me that you extend your graph on both sides to show me that you understand it has a vertical and a horizontal asymptote on all of those. And that absolutely matches what my calculator says I should get. An exciting time. I know. Yes. Yes is the answer. We still have more to go. So let's take a look at problem 3. What you don't know is I cut these notes way down this year. Here we go. Modeling an inverse variation. This will be fun. So it's like a word problem. Your math class has decided to pick up litter each weekend at a local park. It's so sweet. Each week there is approximately the same amount of litter that people have thrown in the room. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. So what I want you to see is as the number of students, it looks like the number of students is increasing, the time is decreasing. Well, that's nice. And that makes sense, right? What do they say? More hands make a lighter load or something like that. Like you want more people to help. It's so nice to help. So I'm going to test for inverse variation and I'm going to see what my constant of variation is going to be because one going up, one going down. So I take my y's. This is essentially my x's. This is essentially my y's. And I divide by my x's. Nope, that's the wrong way, Jelly. Maybe I need to review. Where's that at? Here it is. The test for inverse is I take my y's and I multiply by my x's. Don't worry, you're in good hands. So 85 times 3, 51 times 5, 21 times 12, 15 times 17. Ready for this? And just so you know, in word problems, you may not always get like the exact same thing every time. Like that's okay. You want to get as close. Life isn't, if you don't know yet, life's not perfect. There will definitely be minor glitches. So we get 255 for this one. So we're looking for like pretty much what is about constant. 51 times 5. Okay, so we're still at 255. That looks like it's going to be our constant, but let's do 21 times 12. All right, 252. So we're getting pretty good numbers here. I mean, like we said, maybe Sally came and Sally's not quite as good of a helper as everybody else. So maybe that's why that one's just thrown off a little bit. All right, so I'm just going to go ahead and since I got 255 the most, I'm just going to call K equals approximately 255. You can say even 254 if you wanted to average it out. If you really wanted to be specific, you would average those. Okay, so I decided I was going to test for inverse. I determined the two things and I assigned them for x and y, are n and t in this problem. I solved for k already. Yeah, there it is. It's 255. And I'm going to make a new equation with k filled in. So it would be y equals k divided by x. So in this case, my time is my y, my k is 255, and my x is my number of students. And how many students should we expect to be complete? So that's like my generic. This equation will work for any amount of students or any amount of like if you're like, well, this is how long it took, how many students were there. So it will any amount of students or time. So you can like figure out, you can use that to predict the future. So it says how many students should there be to complete the project in 30 minutes? So 30 minutes is a time. That goes in for T. So I do 30 equals 255 times N. Move the N to the other side. So 30N equals 255. Divide by 30. People always hate it when the variable's in the denominator. It's like a freak out moment. So 255 divided by 30. Come here, calculator. 255 divided by 30. 8.5. So we're going to need 8.5 students. And While I know sometimes we have a very sleepy student and sometimes they're half here, we're just going to say we're going to need 9 students. I would prefer if a full student came, not just half of them. Okay? Now, yes, I know. There's more. It's very, very, very exciting. We're going to talk about sometimes things happen directly and inversely at the same time. It's so exciting. So if you see the word jointly, please understand that means it's going to be multiplied. Like it's going to be like a kxy. Okay? So it's going to be like multiplied together. Now, if you see, okay, what if it's like, ooh, jointly and inversely? Oh, this is going to be fun. So jointly means multiply. So those are going to be together, and inversely means divide. So I'm going to get z equals, because it says z. Let's see, I always write k. Just start with k. Z equals k, jointly with x and y, so boink, boink, inversely with w. Boop, boop. There you go. Now let's do another one. So here's jointly with x, inversely with the product of wy. So directly means multiply, inverse means divide. Z equals K. Just put that K on there automatically. Some people don't do that. Directly with X, so there's direct, and inversely, there's inversely with the product of W and Y. There you go, and that's how it works. So if you see with the word varies, you write K. That's going to be big tomorrow. If you see the word directly or jointly, that means multiply it with K. That's like the tiniest multiply sign. If you see the word inversely, that means divide it with K. Okay, here we go. Okay, get it? The number of bags, so it's n, needed to reseed a yard varies, that equals k, directly, that means multiply, with the area, a, to be seeded, and inversely divided with the weight, w. So just focus on the purple things. Ready? Let me highlight them in purple, even to emphasize. Pink, purple, I don't know. N varies directly with area and inversely with W. Okay, let's go ahead and fill in with just letters. Generally equation before you plug in. Okay, N varies directly with area, inversely with weight. Now I'm going to find K. It takes 2 3-pound bags to seed an area of that. So N is 2, that's for N. 3 pounds is weight. 3,600 is area. And then just hold on to this. We'll get that in a second. Let's find K. So I'm going to replace N. So instead of writing N equals, I'll write 2 equals. I don't know what K is. Fill in area with 3,600. Divide by W of 3. Okay. Multiply by 3. 6 equals K times 3,600. Divide by 3,600. Let's not use a decimal. Okay, let's use a fraction. So it's going to be it's going to be over 600. I just want to verify so I don't do the whole problem wrong. Okay, 1 over 600. So 1 over 600 equals K. So there's all my work for finding K. What is my equation with just K filled in? So I'm going to take this equation and just replace K. So N equals, okay, so K is 1 over 600. That replaces my K. And then I keep A and I keep W. Now, let's answer the question that's being posed. I'll put it in blue. It says, how many 3-pound bags, that's W, will seed this amount of area? And this is like absolutely true, right? Like if you guys think about it, when you go to the store, you need to consider how big is the bag of grass seed and how much do you need to cover. And as one thing gets bigger, the other thing can get small. Like it is definitely an important and like an applicable problem. So how many bags do we need if I have an area of 9,000 and I still stick with the 3-pound bags? And this, I hope this makes sense. Like the number of bags you need will go up the more area you have, but the number of bags you need will go down with the weight of how big the bags is. So hopefully that makes sense. I mean, if you think about it logically, I bet you be like, oh yeah, that makes sense. That's just my guess. Okay, so I do. 1 times 9,000 is 9,000 divided by, I could do 6 times 3 is 1,800, but I just want you guys to see how if you just be very careful with your parentheses, you just do it like that. So I need to buy exactly 5 bags. And you could use that equation for anything, for any like size of a yard or how big a bag would be. All right. If you haven't had fun yet, don't worry. Your fun's coming right here. We're going to go ahead and talk about something called potential energy. Gravitational potential energy is a measure of energy. It's like how much energy, like if I were to stand on top of a building or I mean and jump, and of course there's a soft mattress, but I would have less potential energy than my husband because my husband weighs more. So because like as something falls, the bigger it is, the faster it. So there you go. Not the faster it falls, but like the more energy that's made. So anyway, potential energy, let's go ahead and cost that's PE, they said, varies. Oh, we know varies isn't important and directly is important with an object's mass m and its height h above the ground. So how big you are and how high above the ground you are. Um, physicists use g to represent the constant of variation. Oh, so they actually want us to use g instead of k, which is gravity. This skateboarder in this photo has a mass. Let's go ahead and put his mass of 58 on here. His mass is 58 kilograms. We could do a quick Google search on how many pounds that is, but mass of 58 kilograms. And his potential energy is that. All right, let's get the general equation before we plug stuff in. So I'm going to read through. It says, I'm going to make the pen size a little bit bigger. Potential energy varies. Remember, they want us to use G instead of K. I mean, you can use K here. I'll use K just to emphasize and then we'll replace it with G. Varies directly, so multiply, with an object's mass and height. So it didn't like use the word inversely, so we're still on like the directly. It says directly with mass and height. Okay, so there it is. However, if we read further, they want us to use G instead of K because G stands for gravity. And it looks like we are going to solve for gravity here. Gravity is constant, by the way. So now what we're going to do is find K by filling in those numbers. So we have mass getting filled with 58. That's M. We have potential energy, PE, getting filled in with that number. And his height, oh, here it is. His height is 4. So I'm going to write, instead of writing PE, I'm going to write 273.6 joules, but I'm going to leave the units off. I don't know what the constant is, G. I do know his mass is 58, and I do know his height is 4. So I'm going to get my calculator. I'm going to do 58 times 4. So I get 2273.6 equals G times 232. I'm going to do 2273.6 divided by 23. Oh no, not 23.2, it's 232. And yes, that is true. If you look up gravity, it is 9.8 meters per second squared. So I'm very happy with that answer. So 9.8 is my G value. So the next thing we need to do is make a generic equation. So potential energy is equal to my G value of 9.8 times my mass times my height above the ground. And if you guys ever take physics with me, like that is a huge formula. It's potential energy equals mgh, mass, gravity, height. So that's actually a perfect equation. So now we're going to apply it to the final question. So the question is like, okay, so now that we have like an equation from this skateboarder, what is the potential energy if we have this size of a skateboarder at the same height? So that's going to replace m, and height is going to be the same. So it is the same, the skateboarder is on the same, what do they call it? Half pipe. All right, so we are going to get, I'll change to purple because that's this guy. The new guy, his potential energy is 9.8 for gravity, But now I have a new mass. I have a heavier person of 65 kilograms and the same height. So we're going to grab our calculator. We're going to do 9.8 times 65 times 4, and potential energy is 2548, and that's measured in joules. Energy is. Oakley dokley. Oh, I want just noted that was in my way. So let's look at got it number 5. Ready, ready, ready. How much potential energy would a 41 kilogram person have on a 10-meter diving platform? We would do potential energy equals 9.8 times their mass times their diving board. And then we would get an answer of, ah, my hope is that you're plugging this in too. Yes. I would also just take your time, just maybe pause these videos. You don't have to go straight through them. You can pause them and come back to them. All right, and excuse me, calculator. Let's see what this here. What does this ask about? This, I remember this being a cool question. Let's say that you have an 80 kilogram person on a 6-meter diving platform. So that would be 9 times 8 times 80 times 6. They said, at what height should a smaller, half the size of a person, a 40 kilogram diver, stand to have equal potential energy? So they're saying, like, okay, so if I have a smaller person, what would their height have to be so that this and this are equal? Well, if you're cutting the person's mass in half, then you need to double their height. That'd be like, well, I weigh more than twice of my daughter, but let's just say I weigh twice of my daughter. For her to create as much potential energy off a diving board as I would create, she would have to be, let's just say I was double her. She would have to be double the height because she's so little, she would have to accommodate for all the energy that I have just from my weight. So hopefully that made sense. Okay, it says describe the variables in this given situation. This is very important. Let's go ahead and write it out. P varies. P varies. Oh, I don't want that takes care of all those things I just X'd out. P varies. I'm going to use directly. I could also write jointly, PS, if I want to. I'll put jointly underneath that. With Q, R, and T. And inversely with, did I spell that wrong? S. I feel like I did spell inversely wrong, but that's okay. I'm just going to pretend like that didn't happen. Understanding that, like, if they're on the top, they're directed jointly, and if they're on the bottom, that's inversely. There you go. I think I'm missing an E right there. I don't know. All right. Well, this was fun. I hope you guys enjoyed it. And we shall see how you do tomorrow. I just said tomorrow.